In this demo, we'll look at how we can work with sensitive information during development. We'll learn how to define user secrets for applications using the command line tooling. The user secrets provider will load these secret configuration values. We'll then see how we can manage user secrets within Visual Studio. It's not uncommon to need to configure connection strings or API keys for your application to function fully. Earlier, we integrated with a third-party products API to retrieve product information. We'll open the program.cs file for the products API, and we're going to make a small change. I'll uncomment this code, which introduces a low-tech check for an API key header with a secret value. This will be used to authorize consumers of the API. Please note, this is not at all secure, and it's only for demonstration purposes. If we open up the Products API client inside the Tennis Booking project, we'll add a breakpoint here that will be hit if we fail to get a success status code from the Products API. If I start debugging the application, after a few moments, that breakpoint is hit. The response includes a 401 status code returned by the server because we're unauthorized to access the API due to our new API key requirement. If I continue debugging, the home page loads, but it no longer shows the products at the bottom. We'll update the Tennis Booking application to support the configuration of an API key to use with the Products API. First, we'll add a new string property to the external services configuration file to hold an API key. A tempting option is to provide the configuration by adding it to the app-settings.json file, providing a value for the API key under the Products API configuration. Returning to the Products API client, we need to amend the code to send the API key as a header. I'll paste a new line of code here that adds a header to the request. It loads the value for this from configuration. If I rerun the application, our breakpoint is no longer hit because it receives a success status code from the Product API. The home page loads, and it includes the product information. So, all good, right? Wrong. This is a really bad practice. My app-settings.json file will be checked into source control, and now this secret API key is stored in plain text for anyone with access to the repository. During development, we often have access to development time versions of external resources, and usually don't access the production ones. Even so, we should avoid the risk that this introduces. So, wrist slapped, we'll remove the key from app-settings.json. Instead, we'll use a development time feature called User Secrets. We can right-click on the Tennis Booking project from the Solution Explorer and choose Manage User Secrets from the menu. A file named secrets.json is opened in the editor. You won't find this file in the Solution Explorer because it doesn't live with our solution files. If I right-click on the file, we can view the containing folder. User Secrets is a development time feature provided by .NET. The User Secrets files are located under the current user profile inside App Data and outside of our source control. Each application is allocated a unique GUID used for the directory where that secrets file will be located. It's important to be aware that the contents of these files are still stored as plain text. The contents are protected under your user profile, but those with access, such as system administrators, may still be able to access these files. The corresponding user secret ID is added to the project file so the configuration provider can locate the correct secrets.json file. We can add secrets to this file directly inside the editor or use the .NET command line instead. I tend to use the command line to manage user secrets because it's quick and convenient. I'm at a prompt in the directory where the Tennis Bookings project lives. We'll use the .NET CLI to manage user secrets, which we can do by passing the user secrets argument. We're creating a secret, so we'll use the set command. Now we must provide the name of the secret that we wish to define. This uses the hierarchical naming format with colons separating the configuration sections. We'll provide the full key name for the API key used to access the Products API, and then we can provide a value. Running this command saves the secret into the secrets file on my local file system. We can use the list command to see the defined secrets. The value of this secret isn't encrypted, but at least it is prevented from being included in source control and is accessible only under my user account. You will still probably want to avoid storing production secrets this way. Returning to the editor, we can see the updated secrets.json file now includes our API key. We could of course have modified the secrets.json file directly in the editor. Now when I run the application, the breakpoint is no longer hit and the products are successfully loaded from the protected products API using the API key provided by our user secrets file. This happened automatically because in the development environment, the user secret provider is included by default to load configuration values from those defined in a user secrets file. User secrets help protect non-production secrets during development. But what about production secrets? Stick with me and we'll answer that question. So far, we've learned that sensitive configuration information should be protected. In this demo, we'll look at how to securely define and load sensitive information in production using a service called Azure Key Vault. For the purpose of this demo, I'll be applying my configuration during development, having already authenticated to Azure using the Azure CLI. I won't cover the specifics of the Azure authentication steps in this course. I recommend viewing the Microsoft documentation and relevant courses here at Pluralsight for a deeper dive into using Azure services within .NET applications. So for demonstration purposes, we'll pretend we're using a production API, and before we proceed, I'll update the products API to accept a production API key. If I run the application, we cannot access the products API and we receive a corresponding status code. To provide our production configuration, we'll visit the Azure portal. I'm going to access the Key Vault service. I've already created a vault for the tennis booking application to use. If I open the vault, we can see some properties, most notably the vault's DNS name. We'll need this later when we add the Azure Key Vault configuration provider to the tennis booking application. From the menu, I'll select Secrets. I've got no secrets defined at the moment, so I'll create one for the API key of the Products API. The name must match the hierarchical configuration name within my application configuration. But as you'll see, the colon character is not permitted within the name of secrets defined in Azure Key Vault. Instead, for Key Vault, we need to use a double dash character as the section delimiter. The configuration provider knows how to replace this when it loads configuration settings. I'll provide a value for the API key matching the product API key we defined in the products API. The defaults for the other options are fine for now, so I'll click Create. Our new secret is added to the vault. We can now enable using Azure Key Vault for the tennis booking application. To support this, we must add two NuGet packages. The first is Azure.Identity, so that the application can authenticate with the Azure services. This library will search several predefined locations for credentials that it can use when sending requests to Azure from a .NET application. We'll install the latest stable version, and of course we need to accept any license agreements. The second package we'll add is a bit of a mouthful. The azure.extensions.aspnetcore.configuration.secrets package includes the configuration provider for Azure Key Vault. I'll select the package from the search results and click Install. Again, we need to accept the changes and license agreements. With this completed, let's check the project file. Both packages have been included as references in our project. Since Azure Key Vault is not a default configuration provider, we will now need to enable it as a source for configuration values in our application. Inside the program file, we can achieve this by customizing the configuration. The Azure Key Vault package includes an extension method on iConfiguration that makes this process very simple. This method requires the URL for the key vault. Remember that DNS name I highlighted in the overview for the key vault in the portal? Well, that's what we need to use to access the service. Rather than hard code it, we'll add this to the configuration in a few moments. I'll include a placeholder in this string to accept the key vault name from configuration. For the configuration provider to authenticate, we'll explicitly specify that it should use the default Azure credential that the Azure Identity Library will have located. We need to include the key vault name in our configuration, so we'll add it in the app-settings.json file. And that's it. Since I've authenticated the Azure CLI on this development machine, I should be able to run the application successfully. It will load the API configuration value from Azure Key Vault into the application configuration. The breakpoint in the Products API client is no longer hit because the request to the Products API succeeded. Azure Key Vault is a robust and secure way to store secrets for applications outside of the development environment. Now that I've demonstrated the configuration loaded from Azure Key Vault, I want to make a final change. Do you see any problems with this setup? Strictly speaking, this works, but it requires me to authenticate the Azure CLI before Key Vault can be accessed. In all likelihood, in a real-world scenario, access to the production vault should be restricted so that my personal Azure login doesn't have direct access to it. You may also have been shouting, "What about user secrets?" We can amend this code so that it only adds the Azure Key Vault configuration provider when in production. We can access and check the current environment from the builder, and then wrap this code so that it's only called when we're in that production environment. This allows us to use user secrets in development and Azure Key Vault for production. Before moving on, we'll make one further change so that the Products API acts as a non-production version once again by updating the API key it expects. Combining user secrets for local development and Azure Key Vault for production is an excellent solution to ensure we don't expose sensitive API keys and secrets.